Welcome, this is Jackie Cambridge. Welcome to one of our short videos presentations to help your NEBOSH health and safety qualification. In this particular session, we're just going to have a look at hazardous chemicals. So, hazardous chemicals and hazardous substances, they occur in a variety of forms. Think about chemicals and hazardous substances that you have in your workplace. What are the different forms that those hazardous substances can occur in? There might be a hint in the picture. So what different forms can you think of? Depending on what you're probably going to have some liquids. That's usually the most common chemical form. But you might have some solids. You might have dust or smoke, which is a mixture of partly combustive materials and combustive materials. There may be some mists, which is an airborne liquid. You might have a gas, which is a substance at normal atmospheric pressure, which will just move around and fill the area that are available to it. You may have some vapour, and again, vapour is an airborne liquid. If you fill up your car with petrol and you see the little shimmer as you pull the nozzle out, that is a petrol vapour. And you've got fumes. Fumes are a very small solid, but they're normally very, very small, but they're normally associated with metal. So you have welding fume, very, very small amounts of metal particles that you can breathe into your lungs. You might have some fibres. Fibres tend to be long and thin, so you hear about asbestos fibres. You may also hear about asbestos dust. So even though asbestos in its natural form is a long, thin fibre, sometimes it's contained in other materials like cement or concrete and things like that. So sometimes people will talk about asbestos dust as opposed to asbestos fibres. So you've got a variety of forms. So when we're looking at complying with the control of substances hazardous to health regulations, the first thing we do is, have we got any substances, and then consider the form of those substances, because we know if we know the form, we can then consider how's it going to get into our body, how do we need to protect ourselves. As well as the form of substance, we've then got the classification of different substances. So we haven't got the old-fashioned triangles anymore. We've now got the diamond shapes here. So you've got the skull and crossbones, which means danger. But this symbol, it's an indication symbol, and it can be used for a variety of different hazardous substances. You've got flammable. You've got oxidizing, is the flame with the 0 in it. You've got explosive, corrosive, which means burns on contact. You've got compressed gases, harmful to the environment. We've got the new symbol, which is an exclamation mark. And again, this is an indication of danger and can be used for a variety of substances. So it's giving a warning, and that's used for things like irritants. And then the other new one, you can see in the bottom right-hand corner where you see the head and the chest. This is a symbol for sensitizers, which cause allergic reactions, carcinogens, which cause cancer in the person exposed, and mutagens, i.e. Substances which can affect the unborn child, okay? But you'll see the warning symbol and the danger symbol on a variety of substances, because they're what we call the indication of danger. So you might see that one and then other symbols. So in the realm of things, warning is lower risk than the danger one. Okay, so we've got some hazardous substances, variety of classifications. Let's look at what they can do to us. So some substances have acute symptoms. Acute means it affects you immediately on a single exposure, and it may well be that the effects are reversible, but not all the time. If you have an acid, you get it on your skin, it's an acute effect, affects you immediately with a single exposure. However, we've also got chronic effects. This is where you're regularly exposed to a hazardous substance or a hazardous agent, and over a period of time, it's going to affect you. And there may be a gap between you being exposed and then having the symptoms. So we've got acute and chronic, and it's not necessarily either or. You may have some substances which have both acute effects and chronic. So you drink some alcohol, the acute effects are you feeling maybe a bit lightheaded. Chronic effects would be cirrhosis of the liver. So, just a substance like that, two different effects. We've got a new classification with our new chemical symbols, and it's called an aspiration hazard and it's airborne droplets. And particularly that's important now at the moment with COVID, because one of the ways that they think that's coming into our body is if we're breathing in those very small droplets of air. So it's called an aspiration hazard. Sensitizers, as I've mentioned, sensitizer is a substance that causes allergic reactions in certain people, not in everybody, in certain people. And usually it's an allergic reaction to the skin or an allergic reaction in your lungs, i.e. asthma. Some substances have one or more target organs or target systems. This is where you've got a substance, it gets into your body, it gets into your blood, it's circulated around in your blood, and then it seeks out and attacks one or more of your organs. So if we get in contact with mercury, it gets into our blood, it attacks our nervous system and our brain. Benzene and solvents do the same thing. Phosphorus attacks the bone, lead attacks the bone, but they get into the blood, they circulate around, and then they target a particular organ. Whereas a local agent is, it hurts you where you're in contact with it. Acid on skin, that's a local agent because that's where it's going to hurt you. So we have our hazardous substances, and when we're thinking about those substances, we need to think about what are the ill health effects? What can it do to a person? And it may be, if you hit the jackpot, you can have some acute and some chronic. It might have some local effects, and it may also have a target organ. So if we've got a hazardous substance, think about those forms. How's that substance going to gain entry into my body? We've got a variety of different routes of entry. Inhalation through the nose, ingestion through the mouth, absorption through the skin, injection is via a punch or a sharp going through the skin, and instillation via the eyes. Inhalation is the highest risk because anything that's in the air you're going to breathe in anyway. Ingestion tends to be the lowest risk from a workplace perspective, highest for food poisoning, but lowest from a workplace perspective. But absorption, some substances have the ability to penetrate through the skin. So if you ever see an abbreviation of SK on a label or a manufacturer safety data sheet, it means it has the ability to penetrate through the skin, even if there's not a cut or a graze. So things like solvents can do that. And some substances you may inhale them, but they might go in via another route as well. So if we're using substances which splash, perhaps absorption needs to be considered as well as inhalation. As well as our classifications, we have a system of standard statements for our hazardous substances, and this is a global standard, not just a European but a global standard. So any chemicals, manufacturers and suppliers are using standard symbols and standard phrases. So I've just put a couple of each here. So you have hazard phrases which tell you about the hazards, and precautionary statements which tell you what are the typical things that you should do or not do to ensure the substance is used safely. So we've got a couple there. H240, heating may cause explosion. H320 causes eye irritation. Our precautionary ones, P102, keep out the reach of children. P271, use only indoors or well ventilated area. And you can see from the numbers there are over 600 hazard statements, over 600 precautionary statements, and it's down to the manufacturer and supplier to select the most appropriate ones so that they can use this standard terminology. And on the label, you might see the phrase without the number. On the data sheet, you might see the number without the phrase. But if any manufacturer is using these statements, they all have the same meaning. And we've got a lot more than we used to have in the UK. We used to only have about 60, but now you can be a lot more specific. In the past, it might have just said irritant, but now you can actually say, irritates the eye, irritates the skin, etc. You can be more specific. So you're going to look at the label and the manufacturer's safety data sheet to try and identify. This helps you to identify what are the hazards and what do we need to do to protect people. So you'll see on the label, usually on the chemical label, details of the supplier, the name of the substance. So here we've got acetone, any hazardous constituent parts. So if it contains benzene or lead or something like that, your indications of danger. So here you can see you've got the exclamation mark, which means warning. We've got the compressed gas one, and we've got the flammable symbol. You've got your hazard and precautionary phrases, and on this label you've got the phrases without the numbers. On the data sheet you may find the number and the phrase, or just the number. Equally, internationally, there is a United Nations system for classifying hazardous substances, and they are all given a unique chemical abstract number, so a CAS number. So you can see on this one it's 67641. So that should mean any company all over the world, if they manufacture or supply acetone, it should have the same chemical abstract number. So there's quite a lot of information that you can just get from the label. The control of substances hazardous to health regulations as amended. These are the main regulations in the UK, so I'm just going to give you a quick potty tour in relation to these regulations. And these cover hazardous chemicals and biological agents as well. So when you're studying biological agents, COSHH is the law for those as well. So first question, does our work involve any hazardous substances? Even some of the substances that you might use at home, if you've got a substance such as washing up liquid, it is classified. It's got one of those symbols, it's got the warning symbol. That means it is a hazardous substance. So if you bring it into the workplace, COSHH applies. We're still not saying it's a high-risk substance, but if you've got a substance that's got any of those chemical labels on them, if you've got a substance that's got a chemical warning label, then that is a hazardous substance and COSHH applies. So we're going to do a suitable and sufficient risk assessment, looking at the hazards, looking at what we're going to do about it. Then once we've done the suitable and sufficient risk assessment, just like majority of European legislation, we're going to take steps to either prevent and control exposure. To use what is provided, if I provide you with a ventilated booth, some local exhaust ventilation or some PPE, I'm the employer, I've got to provide it. Under COSHH, you've then got a duty to use what is provided. So it's a two-way responsibility between the employer and the employee. If I provide any engineering controls, such as a local exhaust ventilation unit, some additional ventilation, a glove box, or any extraction system, anything like that, I've not only got to provide it, I've got to make sure that I maintain it so it's in good working order. Depending on the nature of the substance, I might need to do some monitoring or sampling. You can't put your finger in the air and go, oh, there's this amount of carbon monoxide, there's this amount of toluene. So if we've got a high-risk substance, to check that people are not being exposed to too much, we may do some sampling and monitoring. Equally, if the substance has a known ill health effect to humans, we may then do some health surveillance where we check your health is not being affected. So for some substances, we can take a swab of your skin, we can get you to breathe out, we can take a saliva sample or a urine sample or blood sample, and it helps us identify that you're not being exposed to more than you should of this particular chemical. We always need to have a plan B. So we've got to have arrangements for either accidents or spillages, and that could be small scale if you've only got cleaning products, it could be large scale if you've got enormous amounts of a hazardous substance. So it's making sure you've got arrangements to deal with accidents and emergencies. You haven't just got them, you've got procedures, you've tested them, you've done drills and practices, and any equipment that you might need for dealing with those particular accidents and emergencies, you've got that available as well. So lastly, this is a piece of legislation that came as a result of a European directive. So no health and safety legislation that in this form would be complete without the training, information and instruction. It's not sending your staff away on a weeks-long course on how to use chemicals, but what do they really need to know? What the chemical is used for, how to use it, the ill health effects, the routes of entry, so they can then protect themselves, how they use it, how they use any control measures, etc. What they do if there's a problem, what they do if there's an emergency, but also letting them know what any ill health effects are so they can keep an eye out and report it if they start to see any of those symptoms before it gets too late. So a potty tour, the control of substances, hazardous to health regulations. These cover hazardous substances and they're about protecting employees exposed to hazardous chemicals during their day-to-day work. So I've mentioned a suitable and sufficient risk assessment. So when you do the assessment, you're not going to use the standard 5 steps to risk assessment. That's for general activities. COSHH gives us some additional things to look at because we're looking at hazardous substances. So the first thing, we're going to look at the substance and ask some questions about the substance. What is the substance? What's its classification? How much are you using? What are its ill health effects? How do we store it? These types of things. What's the concentration of the substance? So ask ourselves some things about the substance that could increase the risk of injury. Then have a look at how are we using it? Are we dipping it? Are we spraying it? Are we, how are we actually using this substance? Because depending on how we're using it, that's going to affect the risk level. Then we consider the people. Who's exposed? Who could be at risk? This will be the number of users. Have you got any vulnerable people? Is this a chemical that just affects one person? Or if there's a spill, could it affect everybody? So things about the users. Have we got any vulnerable people? People who might be at greater risk. Then lastly, some people miss this one out, but I just think you also need to look around you. Where's the substance being used? Because if the workplace is small, you're likely to be exposed to more. If the workplace is large and well ventilated, you're likely to be exposed to less. Is it indoors or outdoors? What's the lighting like? If you can't see very well, you're more likely maybe to splash or spill the chemical. So what we're doing here, we're trying to identify the factors that could increase the risk of injury or reduce the risk of injury. We're not looking at control measures, we're asking the questions. And the more questions that you ask, the more reliable your assessment is going to be. So we'll just have a look at a few of the factors that you would consider when completing a suitable and sufficient risk assessment of a hazardous substance. So you've got the substance, as I've mentioned, its properties, classifications, route of entry, the form or forms of substance. Does the substance have a workplace exposure limit? This is a limit on how much legally an employee can be exposed to in either 15 minutes or 8 hours. We're going to have a look at that just in a moment. The use. How are you using it? How long are you using it for? Is it ad hoc or using it all the time? What type of work are you using the substance for? Have you got any activities like maintenance and cleaning where you might use have you got any activities like cleaning and maintenance where people might be exposed to high levels of the substance? Are you using substance A? Are you using substance A and substance B? Or are you actually mixing them together where you're going to get a completely new substance with potentially different ill health effects? We look at the individual, number of people exposed. Have you got any vulnerable people? Is it the user? Is it others? If we've had any health surveillance, what are the results? Do they show that people are being protected? And we've got the issue with synergistic effects. So basically, synergistic means that some people, for instance, if you're a smoker and you're exposed to certain hazardous substances, you could be at greater risk. That's what synergistic means. Basically, 1 + 1 = more than 2. You're at greater risk. As I've mentioned, have a look around the environment as well, because there could be some environmental factors that increase the risk. Is it indoors, outdoors? What type of ventilation have you got, etc. The more questions you ask, the more information that you get, the more reliable your evaluation of the risk. Because is it going to be high, medium or low? It could just be washing up liquid. It may not be a high risk substance, but we're just checking. Once you've done your assessment, then it's about taking steps to control and reduce the risk to our employees. And it may be sophisticated or unsophisticated. So you may be already familiar with the term hierarchy of control. We use it generally with risk assessments. So this is a range of measures that starts with the best and ends with the least. So you've just got, for your chemicals, you've got practical. Can we eliminate the use of that substance? Can we substitute for a lower risk one? If you've got a toxic substance, have we got one that isn't toxic? If it's got a solvent in it, can we have a water-based one? If you've got a powder, can we buy it as a paste? Then can we look at the design of the task to reduce exposure? Can we contain it in a glove box or a fume cupboard? Can we use local exhaust ventilation? Can we use general ventilation just to reduce people's exposure? Look at the way that the substance is being used and work patterns and work methods. Job rotation, limiting time, using a method where people don't expose themselves to a high degree of the substance. So rather than spraying a paint, can we brush it? Then we've got procedural controls. Procedural controls includes training, information, instruction, but cleaning, personal hygiene procedures, these types of things, putting up a sign, so procedural controls. And then at the bottom of our hierarchy, like any hierarchy, we've got personal protective equipment, anything you wear or hold to protect you. And it's at the bottom because if we can do as many of the control measures from the higher part of the hierarchy, you may not then actually need your PPE, you're less reliant on it. Just to say, a hierarchy of control is a range of control measures, but there isn't just one. The hierarchy of control for dust might be different from a hierarchy of control for a solvent. The hierarchy of control for noise is going to be different to the hierarchy of control for electricity. It's just a generic term, but most hierarchies start with eliminate, they have a substitute in there, and they tend to end with PPE. But depending on what the hazard is, the bits in the middle may be a little bit different. I mentioned the term under substance of workplace exposure limits. So a workplace exposure limit, we have some substances where there is a limit on how much people can be exposed to. It's airborne substances only, and the limits are given over 8 hours, i.e. assuming that you're working with a substance over a typical day, or for 15 minutes because you're only using it for a short period of time. Workplace exposure limits are part of COSHH, but they're listed separately in a document called EH40, Environmental Hygiene Guidance Note number 40, and there's a table just like the one you can see on the right hand side of the screen there. And so it gives you the name of the substance, its chemical abstract number, its long-term and short-term exposure limits, and the exposure limits are given either in parts per million or milligrams per metre cubed. If it's a solid, it's usually a milligram per metre cubed. If it's a gas or a fume, it's usually parts per million. And some substances have an 8-hour figure and a 15 minutes, some have either or. But these are the limits that in a typical day or a 15-minute period, people mustn't be exposed to any more. So you mustn't expose people to more than the well. However, if you've got a high-risk substance that causes asthma or cancer, just not exposing people to the well is not good enough. You've actually got to ensure that you're exposing people to as low a level as reasonably practicable. So if you're exposing people to a substance and it causes cancer and you haven't taken any control measures, by putting in a ventilation system, it's going to reduce the risk. So it's putting in control measures to reduce the level of exposure to as low as reasonably practicable for those high-risk substances. And if you want some sampling done, this is where you might have someone called an occupational hygienist, and they come in and they take these samples and they measure the air and they can tell you how much substance is in there. And what we're after is not just what's in the air, but how much people are being exposed to in their day, their general working day. So that's workplace exposure limits. In relation to control measures, you might have local exhaust ventilation units, LEV, and you can see a couple of different examples here. And the purpose is to extract the fumes, the vapours or the dust before they get into the breathing zone of the worker. So these are engineering controls. Because they're an engineering control, we've got to make sure not only are they used, but they're maintained. So COSHH says to us, if you have any engineering controls, they must be thoroughly examined by a competent person at least every 14 months. And the results of those thorough examinations must be recorded. And it's not a mistake, it is every 14 months because LEV systems work differently at different temperatures and different levels of humidity. If you always do it every 12 months, you'll always be testing and examining it at the same time of year. Whereas if you do 14 months, you rotate through the different seasons and you can make sure that it works as effectively in the summer as it does in the winter. If you've got lower risk substances and small amounts of them, you may have dilution ventilation. There's a degree of extraction here, but you haven't got the velocity that you have for LEV, and you're relying on the fumes and vapours to go up. But it will reduce the amount of substance in the air, but it's for low risk substances. For even lower risk substances, it might be just opening a window or a shutter door or having a fan, just to keep the amount of substance in the air below the workplace exposure limit and where it's not going to cause any problem. As I've mentioned, you can't put your finger in the air and go, oh, that amount of toluene. So you might need to do some monitoring. So we'll just have a quick look at a variety of bits of equipment that you can use. You may do some personal sampling. So this is where someone wears a pump and a tube and a sampling head, and it measures how much of the substance the person has been exposed to. So on the right hand side, you can see this chap there. He's got a sampling head and it's connected to a pump. That particular head is going to measure dust, and they wear it for the whole day. Then they send the filter away. The filter is weighed, and they would work out how much dust they've been exposed to. If it's a fume or a vapour, they have the same pump, but they have actually a glass tube instead. And again, that's sent away for analysis. And that's the best form of sampling because it's measuring how much you or a person has been exposed to. We may use something called either a Draeger tube or a colour stain detector tube. As you can see, these are in the bottom right-hand corner. You break the ends off the tube, you put them in a pump, you pump about 10 times, and then they would change colour if they detect the hazardous substance. But you need to know what the substance is that you're testing for so that you get the right tube. Those grab samples and Draeger tubes are only for fumes, gases and vapours, not dust. Alarm sampling is when we sample the air all the time, and if it detects the substance, it sounds an alarm. So at home you might have a carbon monoxide detector which does exactly the same thing. If we've got a substance and we know people are likely to be exposed on a regular basis, we might invest in a direct reading instrument like the little yellow one in the picture here. And this detector only detects a certain substance. It might be hydrogen sulfide, it might be methane, it could be ammonia, but you can do regular checks and it analyses it there and then and gives you a reading, so you haven't got to send it away for analysis. And you can use that to check that areas are okay and people are being protected. The last bit of kit there is called a dust or a Tyndall lamp, and it's used for dust. It's just a very, very bright light for dust and fumes, and it can actually help you see where they're going. It doesn't tell you exactly how much there is, but it can show you if your ventilation system is actually removing the fumes, the vapours or the dust. So depending on our hazardous substance, we may not need to do any monitoring, but if we want to make sure that people are not being exposed to too much, then we can do the monitoring just to then check the levels in EH40 and not being exceeded. So what we've done today, we've done a potted tour on chemical agents and given you an overview of the control of substances hazardous to health regulations. So if you've got any substances at work, as you're going to have, even if they're low risk, we need to just identify what's the substance, what's its form, how can it get into the body, what existing control measures have we got, and then just ensure that our control measures are reducing people's exposure to below the well, and if it's a high risk substance, to as low as is reasonably practicable. So thank you very much for watching. Hope that's been useful for you.